But this is a crusher destemmer, so the stems, takes the stems out, and then it crushes. Here is a mic crusher, and then it comes into our little tanks. We also have our press for our TJ fermenters for reds. Fermentation can take between 7 days to 2 weeks, depending the treatment. For whites, we have to take the skins out at the very beginning. So before, it can go from the crusher destemmer directly into one of the presses, or it can go directly to like a whole berry. We put one of our presses right underneath this elevator. And I'll show you which other presses. Everything that you can see here is on wheels, because we're flexible to adapt to many different processes. Are the cleaning stations. So here what we're doing, we're getting ready for tomorrow, those TJ fermenters. So those are the lids, as you can see, different fittings and gaskets, and then the brain of the fermentation source of blue thing. We call it IFCS. Basically it's a computer that controls the pump over and controls the temperature for each individual of my fermentation, and I'll show you in a second. So they are doing right now cleaning, sanitation to get ready equipment for next week. This is one of my presses, so we have two. If we want it, you can tell here they have wheels as well. So then we can bring this outside and the grapes just fall right into the press, and that's what we do for the whites. So squeeze it, get it, and we can put it in the little fermenters, little kegs, or we can also put it in a larger fermentation, which is right here. So let me show you how the TJ Rodgers, his last name is Rodgers, we call it TJ fermenters. He, together when he was in Cyprus, because he's the founder of Cyprus, he did develop this together with Roger Boulton, Professor Roger Boulton. So TJ Rodgers, Roger Boulton came with this idea. TJ Rodgers donated 152 different fermenters, all the same size, same controllers, because that's the only way we can do fermentation in accurate and precise control for research. We can do duplicates, triplicates, whatever number you want.
So the reason they're the size is because for research purposes.
This is mainly research, but we also produce different wines at this level because our grapes are small lots. We also have those larger, so we have 14 of those fermenters. We are building in capacity for them to have similar controls like we do have in the small one. So this is for scalability, 10 times larger than the TJs. So my TJs are 55 gallons, those are 540, almost 10 times. So then we can do an escalated 10 times. This is more kind of like a closer size for industry. Because we also have like clones, different clones, and I have right now, and I can show you clones for Petit Syrah that we have different vines. So not all the vines can be, we don't have like a large amount of grapes. So we process all to this small. So these IFCS controller systems, what they do, they control the temperature. This is TC for temperature control, PC for pump control, and BC for the bricks. Bricks is the sugar content. The fermentation follows a curve of bricks goes down as alcohol increases. So it's a conversion with the yeast from sugar into alcohol. So the depletion of the bricks, or when it's starting to decrease, then you can see the fermentation is happening. Another thing we have, so the bricks, how do we measure everything, right? So this one is a temperature control. The maximum temperature we set 25 in the jacket. So we have different props in the jacket, in the must, and in the cap. So you see here, everything is color coded. So this one is my cap sensor. This is my must sensor. And the jacket is on the jacket. So it's underneath this, so which is the jacket of the fermenter. So we set up for the jacket, and the valve, this valve, which is connected here, opens and closes the circulation of water to keep the temperature at the set point that you have. So that's the important part here. Now, if you see in the pump, we have a timer. The second TIMR is a timer for the pumps. The pump will come on and off as we program it. So we can change the pump over without needing to be here presently. We just make sure when it's going, it's really working correctly. Those are the little pumps. So these ones in the top, those are little pumps. And so they are controlled by this. As well, then the bricks. The bricks meter is with these 3 hoses and this device. What it measures is differential pressure, 2 different levels. So in the bottom, so one it goes in the bottom versus the atmospheric, and then the other one in the top versus atmosphere. And those 2 numbers, the differential gives us density, and density gives you sugar content, and that's what we call bricks. So here you can see the bricks is 10.92 for this particular. We also do it handmade, so that we take a sample from here, we check it with our another instrument, which could be hydrometer, but here we have a density meter as well. So that one gives us another number to make sure that the numbers here are accurate. Now, scaling this up into our larger fermenters, let me show you this one right here. So here in this tank, we just received today, we are cold soaking. This is Petit Syrah. And we have some devices here. This is a new tool that we have this year in all our tanks. Those are redox electrodes for the redox potential. So the redox potential will tell us if the wine is getting oxidated or reduced. And then we can act in a good timely to do that. We also have, here is our temperature. So the temperature goes inside and controls the jackets on this, opens and closes the jackets. Very similar, or very similar. Here we have these 2 levels of pressure transducers. Those pressure transducers also are gonna give us that differential pressure to give us bricks. So this is just fruit that we just received today. We're about to start cleaning up and making sure and program all this. So let me show you how we program those into the computer right here. Let me just log in first. So that was tank 11, right? So Petit Syrah. So I mentioned this is Petit Syrah. We just received this wine today, these grapes today. So we went through crushing, the stemming, and with the mass pump, we just pump it right into the tank. And right now, we put it at temperature control. Now it has an alarm. But the temperature control is 5 Celsius. So right now it's at 15. So you see our valve for cold run is open. In here, yellow means open and green means close, which is a little bit backwards, but and then they say auto. So then it's programmed to do that. When I go into my maintenance, I can see that my cold valve is 100% open, so that we can see what is happening in the system. Since we just started, this one doesn't have any graphs just yet, but this is my set point. So I go back to my, this also, and I'm not gonna touch it because I will make something wrong in there. But you can do manual pump over, which is we want an external pump. But if you see, they all have automatic pumps in underneath each tank. So those pumps will do the pump over as we program. So that will be under fermentation, which I'm not gonna touch right now. But the fermentation, I can program how many pump overs a day I want to do on those tanks. And I have also the manual kind of processing. If I go to manual, I can operate my pump, I can open valves, etc. So this is how I do. So if we see an overview on tank 1, I have an Albarino. It's still cooling. It's currently fermenting this tank. So in this case, because it's a white, we don't do pump overs. For reds, we do. So this will be the first one, the Petit Syrah that we received today, that we're gonna be doing pump overs. with the system, automatic system. You have any questions so far?
Control 6,000 gallons with this, just going back and forth.
Yes.
Wow.
Yes. So we have 14 of these size tanks.
7,000 gallons.
Yes. We have 14 of these tanks, and we can process. We don't have a lot of capacity to transfer any of this wine into another tank. So if I'm full, my 14 tanks, I'm done pretty much. So I normally try to leave one open to do the rackings or blending, and then put it back in the original tank. So we are limited on the tank capacity. Right now I have all these tanks full, so 6 in this side and 1 in this side, and actually 7. So we did 2 today because we have more fruit than expected. So we have 2 tanks. So my only empty ones is tank 7, 8, 9, 10, 13, and 14. So Friday we're gonna fill 14 and more TJs, because we do sometimes the same in the larger scale and the smaller scale. Something on sustainability that you can see here is that we don't have lights on, except for a few because of the code for safety. We have to keep a few, but the lighting here is natural lighting, so we don't spend any energy. We also have solar panels, and the solar panels are connected to our batteries, so the batteries are what can just provide the full energy that we require. And we can keep going this way. Let me show you some of the experiments that we're doing besides what we have in here. Okay, well, this one is a very cool experiment. They are, this is one of the experiments is one of the professors, David Block, a student. She's doing a master's study. So she's doing control the regular that I show you in the other fermenter. Also the temperature max, and all the pump over, very regular standard operations for the red. In this case, what she did, and you can see that we have 2 pumps. It looks like a circulation system in a human person. But what it is in this one, we have in this vessel, we have the juice. In this vessel, we only have the skins and seeds. We separate them and we place them in a column. So inside here, you don't see it, they are in between a couple of screens. And then we just put everything on that to control the extraction. So we are looking at the extractability of tannins, mainly tannins and color, obviously, which is all the phenols, through that that system. So she has it in an automatic like pumping. So it pumps in and pumps out the extraction of the components that you find on the skins and seeds, which is where the natural fermentation happens. I mean, it's what you do with the pump over or punch downs. So in this case, she's gonna do it separate, like the juice is pumping over the column of the skins and seeds, and it goes back into the. So here you have 2, one goes out and the other one comes in.
And then she measures everything after to see what the difference is, as opposed
Right.
to the way wineries would normally do it.
Exactly,
Okay.
right. Another experiment that we're conducting is exactly what I show you on the redox. So we study this especially with whites, and now we're trying to figure out the reds. So we're gonna be receiving more fruit on tomorrow to process on Friday. Yeah, it's like today is Wednesday. So yeah, so on Friday we're gonna be processing that fruit in a larger tank. That will be this one, 14, because they're gonna be setting up all the instrumentation for controlling the oxygenation as well. How much oxygen or air is injected to make the fermentation not reductive.
So do all your grapes come from here, or you get them from different wineries that bring in your grapes?
Different places. So depending the professor that is conducting, and if they got from another company some grapes, then they work that out. For example, last year we got a lot of fruit donated from several wineries that have been impacted by these fires. We call it the Smoke Taint Project. So Professor Anita Oberhoster, she's conducting from 2017 trials. Obviously, last year was when we have full of all these grapes that got impacted by the smoke taint.
There's like 200 different samples, I think.
Probably, or even more, I'm gonna say.
But the
yes.
wineries, you actually tested for the smoke taint here?
So we all of those went through analytical chemistry that she has, and they have the different levels of phenols, volatile phenols that are related to a smoke taint. Now, this year, we're fortunate that we don't have as many impacted vineyards, so we are doing the same vineyards in a smaller scale fermentation to get the baseline, because some of those volatile compounds, volatile phenols, are already in the grape. And each variety has a different level. So it's not good to say, oh, this is my level that I allowed or not allowed for my grape. It's like, how was it in your grape before it got smoke tainted? Then we can subtract that, and then the difference will be what is smoke impacted, right?
Okay, so you're still doing a lot of work then with the smoke and the after effects
Yes,
of the smoke. Okay.
yes, and actually she's gonna do a force some grapes here. She's gonna produce some smoke in that particular row that we haven't picked anything. I mean, we already picked everything else, but those to see how is the fruit impacted and analyze it with time, temperature, proximity to the fire, etc. Because those are factors that could be very, very drastically different.
So do any of the wineries are eligible to come to you for this assessment of their grapes, or are there certain requirements, certain wineries that you'll take, but you can't obviously take everyone because there's so many wineries here.
Exactly. No, so we work in collaboration with, like Anita Ovehoster, Ron Runevar, the different professors work with different wineries.
Different wineries.
Then those wineries said, okay, this is what I can offer you, and this is the budget that I can help you with, because this is all the time, and the time, our analysis, our equipment, everything has to be in the same kind of like conversation. So once we discuss that and capacity, then we say, okay, how many do you have? Okay, I have 60 of this one. Okay, how many do we need for class? How many do we need for this other professor? So I have like my timetable of like tank capacity, how many we're doing for what. Like I have to say no to a few right now because I'm gonna be full pretty soon in my larger fermenters, and I don't have a place to empty anything.
And the students do most of the work then as part of the education here, or?
Yes, so I have a full staff, which is 2 persons in addition to me. One of them is a specialist kind of in the lab. However, she also comes and helps, and I will introduce both to you. The other person is Fermin, which is right there. Fermin, say hi. So Fermin, he's my cellar master, and he organizes everything in the cellar. So we have our meetings every day. We have our board with what is happening. So then we discuss the details, and then he distributes the work as required. So we have we hire students that are my interns, the winery interns we call. We have right now 6 different interns, and I might have a couple more joining in fall quarter. So we train them. We have them all set up. We train them from scratch, from winemaking. Some of them come with a winemaking experience, some don't have any winemaking experience, and I don't require any winemaking experience. This is the first job they get to make their own wines. So this is fascinating for them. They are very capable, they learn pretty fast, and they are our team to make all these projects happen. We also have each lab, for example, Anita, Ron, they have their own lab or students that are doing a particular project like the one that I was showing here. That's one student from that team, right? And then she was trained by us and helped by us. We helped her to develop this. Anita Oberhoster, she's been here longer than I am. I have been here. So I started 2019, and Anita has been longer, so she is also training several persons on her end, because they have even more other projects, not necessarily the winery, but also outside the winery, as many other professors, right? So some professors are using it more or less, depending their project. This is the first year I'm doing a project for a couple of students, and they are doing, I think, also masters, I believe, with Professor Dario Cantu. And they are studying hybrids. So this is Cabernet Sauvignon and Riesling. That's a hybrid grapes, but they only have like 3 vines of each hybrid. So my size of fermenters are very extremely
smaller than
little,
this, right?
much smaller than this. So we couldn't do this except for their controls, which is the cab and the riddling, which are a little larger. But everything else is just what we call a bucket fermentation. And the protocol was just straightforward to just express the fruit. We also have a project that is internal ourselves. We have a little vineyard plot here, which is what we call the war varieties. So they are very weird varieties that are not very common. So we're just trying to figure out what can we do the best wine that we can produce with those grapes. Here in what we call RMI, another 2 blocks of vineyards are in Tyree, near the airport and Hopkins. So by the airport of UC Davis, we have another 2 blocks. Different viticulturists have different projects there. Some come here. We have a few that came in here. We have like a Chardonnay tank full of Chardonnay juice waiting for a space to be fermented. We also use all the juices that we have here for class. So we have Grenache and Zinfandel and Barbera Rosé. So that juice is waiting for the students to come and ferment. We have Albarino, we have French Colombard, we have Gruner, we have Cabernet. So we have different varieties. Right now we have Petit Syrah, a clone system. I can show you from here, from this variety, from this vineyard as well. Oh, actually, let me stop by here. This is another project we're doing. These are starting fermenting. They arrived on the 10th of September. These ones are a UV project for Oakville grapes. So in Oakville, we have also our research station. So we conduct some grapes, different experiments. This is led by Khan, the specialist, extension specialist, Khan Kurkural. This professor does a lot of vineyard, and he conducted different UV light, protecting the vines from different UV light at different levels. And then we have here, they have 5 different, the control with no protection, and the other 4, like a sunscreen kind of thing for the grapes. So we're trying to figure out, this is the 2nd year we're doing those, or the 3rd year, I'm gonna say. I think it's the 3rd year now. So it's repetition of harvest after harvest to make sure that we get good results and data.
And then this information is published so that the wineries can all take this information and use it? Is this something that you provide to anyone, the results of these tests?
Yes, so especially like the students that are doing a PhD or a master's, they will do a writing, a paper, they will publish it, or they also will put it as a presentation in different seminars. Some of this is also taught by the principal investigator, like the professor that is leading those research, and that he or she will be doing those seminars as well. So Ken Kurkural and Anita Overhoster, they both do a lot of seminars everywhere. They go and teach people and share the results with the industry. So in here, these ones are the Petit Syrah that I mentioned. So the same fruit that I received, but this was selected for the experiment, and we have different clones. This is also Anita's. So she has 12 different TJs. 3 of them are the same clone to identify the clone variability and adaptability and many other analyses that she is conducting with the different students. So those students. Right now, as you see, it doesn't have the brain on top because these ones are already pressed. So we press those ones. Now we're doing malolactic fermentation. Malolactic fermentation is just covering all that to the top, to the bottom to avoid any oxidation. We're just giving enough space for the fermentation. And once they are done with malolactic fermentation, they will get sulfur, cool down, rack, and bottle for analysis. But we're just keeping it like that just to make sure that there are no flies or any other contamination. So all this set is for them. The only thing we control with these brains is the temperature for malolactic fermentation. We set up at 20 on the jacket. So we are talking about the expansion of the winery, and we want to have more on that end, like extend the building, similar kind of like a structure or architectural design with the sustainability as well to get it extended. And we plan to have more large tanks and more space for TJs because we do run out of space to a degree. And it is hard because we need more vessels and more vessels. The other thing that you asked me about what we do with the bottles, right? So, okay, let me show you. So we can come over here. So here we have more. We just received this fruit yesterday. This is Tempranillo that we received from our tyree, which is by the airport. Oh, let me show you. This is our bottling. Obviously, it's not set up for bottling right now, right? It's just
all the bottles go through this little machine?
Most of them,
wow.
Yes. My filling bowl, my bottles will come here, and after they come here, they go in this machine, which, as you say, so cropping here. But this one will have either cork or a screw cap. For our project, we use a screw cap to avoid any interactions of the cork into the wine, so to avoid any external variability. And this is just to put the liquid nitrogen on the bottles and to minimize oxidation. So this one, as you can say, I can just move it with one hand. And we have full of cases that they use for either training purposes, sensory analysis here in campus. We also have it for analysis on just chemistry or microbiology or whatever is the purpose of that particular. We have some that are good examples for the students as a sensory training. So we have all that too. So all of these wines have a number, a lot number, like let's say this is a case 1, this is a smoke taint. And I know that it's a 2017 Cabernet Sauvignon. It's for Anita, that's this number. And this is when it was bottled. So we have all the information. And eventually, I'm getting full here too. So once they are done with the trials, I know. Once they are done with the trials, then we just say, hey, are you done with the trials? And we have to dispose the wine. So right now we cannot sell it.
Okay.
We can transfer bond to bond though. Right now we are able, we are TTV certified or registered. We are a bonded winery since October last year. So we were able to get it bonded. So now we are legally transfer in or transfer out bond to bond, but no selling. We're working on the entity.
So when you say bond to bond, what does that mean?
It's when a TTV can allow you to produce wine that doesn't need to go to the drain, but you can transfer to another location for other purposes.
Oh, so they can take it.
They can take
do something with it and make it and sell it as a
right.
wine. Okay.
Exactly, but I cannot sell it.
Okay.
Exactly. So we have a database that's called Innovent, and over there we just do our work orders, any additions, anything that happens goes into that system. We can actually scan. So this is my mobile. So if I go here, scan this. So this is the lot number. This is my tank. This is my lot number. This is how many gallons it has and the capacity. It gives me some analysis. It gives me that there were some additions and other notes, and I have different students' names in each of that. It's much better in the computer when I can show you, but if they want to do bricks and temperature, which is every single day, they use this and they scan them and then they record.
They don't even have to be here. They could just check it anywhere.
Exactly. You can check it anywhere because it's a web-based database. So we can see the information wherever we do. We also, let me show you, this is also very cool. Obviously, we have much more equipment. This is all for my TJs. A little press over there. Those are my cold rooms. It says TJ Rodgers and Balita. So TJ and Balita Rodgers in their airport.
So you rely a lot on donations for your equipment?
Actually, the whole building was because of donations. Gifts, funds from very generous people. We made this whole project is because of those gifts that we have received. So here you can tell, right, so in this case you have different sensors where we're measuring at any single time. So this is my different props for TJ Bank 1, which is right in here. So this is in pie, so we can see all those displays. Let me see if I have something that makes sense. So we have our redox control. Let me see if I have more. And you can change the timing in here. So I can put a week, 1 week. Those are my sensors, the props that I told you about redox, and each of them has a link to what tank it is. Those are my solenoids. This is my bricks. Those are my larger fermenters. So we can see, depending the number of the sensor, they all have one number, not different numbers. And then you can see here, like I remember 11 is one of my P tanks with Albarino. 9 is my other one. So one is lower than the other one. But if we see in a weekly basis, in a month, you can see how they change. They start going down, 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 and now it's coming back to a better number because this one got reduced. So this one became too low in the reductive character. So this is how we can see all the tanks that have a probe. And it's pretty similar to what you see in the other screen. So, and you can see the lot numbers, the gallons, and the temperature settings. And also you can see my fermenters, my temperatures, and my rooms, because I have different rooms and different temperatures. Well, this one gives me my rooms, my cold rooms. So I have graphs of temperature and humidity on my 3 cold rooms, and my and this one is just my barrel room, which I will show you in a second. And I also have
55 degrees is what you keep it at.
yes,
For the
you
first
have
two.
first 2, and the other one is 72, and I'll show you.
What's in the 72?
And the 72 is a malolactic fermentation.
Malolactic,
Because
okay,
mal
okay.
needs a warmer temperature. Okay. So I have my barrel room, my crush pad, my special collections, my classroom, my lab, my fermentation hall. This is the big cellar that you just walk into. So you can see here we have a lot more differences, of course. What are we measuring? So CO2 is important. So you see CO2 is the green line in here. So it's pretty low,
Okay,
which
so
is
you
what
don't
you
want to
want.
build up a CO2, yeah.
Correct,
right.
and I'll show you what we have for CO2 as
Okay.
well. And then we have the temperature here. We have volatile organic carbon compounds, and those are large particles if it's red. So obviously in the crush pad, if you open the door, you get more particles. Obviously you can see that. If we go, let's say, let's show the front because this one is kind of fun to see. So see our main humidity here. It varies, especially if we open and closes the door. It would more dependable on the outside. We don't have a humidity control here, but this is a number. The CO2 is in the bottom here, so keep it low. We have the VOCs as well, like come up, down, up, down, up, down. So it depends if we open the door, close the door, we have receiving fruit, etc. And the temperature. So the temperature also fluctuates a little bit and is higher or lower depending the external temperature. My crush pad also has these 3 numbers, which is just for pretty much to measure our sensors are working. This is our lab. A special collection is not giving us a very good number. It's all stable pretty much, but it's been like a 60 of temperature, 57 of humidity, and 16.5 the temperature, and the CO2 is low. So I have to make sure my numbers, this is the same information, this is what is connected to my pi. So here is my set point, and the actual. So my set point and the actual temperature. Set point and actual, set point actual, set point actual. I'm not controlling humidity in these 4 rooms yet. We also have in here like special collections, the bottle cellar and the barrel cellar. The bottle cellar is the one I show you. Here we control humidity and temperature. Right now we're conducting a trial comparing stainless steel versus oak with micro-oxygenation. So there's ones used to, so we have 3 controls, which is these 2, and that one is the control. The last 3 in this line, the last 3 pairs, or 6 barrels, those were having a small dosage, so, or larger dosage, and then they just took it off. And this is another dosage, and then of micro-oxygenation, longer term. So it's time temperature. So let me put this one back in here. I'm sure we were just putting samples. Now, here we just have aging wine. In here we have some smoke taint all the way to here. And in this part we have Cabernet Sauvignon from Oakville, also aging on oak. So, yes, so the work here is a lot of taking samples, making sure they are good. This is SO2 in good levels. We top, we come and do the topping of our barrels to maintain them, but temperature control helps a lot to eliminate evaporation. So temperature control, humidity control. When you're talking about food pairing and wine pairing, I always think it's a very personal thing. It depends what you like, because whatever I like is not necessarily, it's like clothes. We like different colors, different fabrics. I think for wine it's the same, because a lot of people have those kind of probably experiences that they say, if you have a spicy food, have something with low alcohol and not too strong on certain characters, or not too alcoholic, like the alcohol is low enough. And other people like it spicy with a natural, like, a strong red wine. So what is the recommendation? Is just try, play with it, and just do whatever you like. I don't think there's one food and one wine necessarily pairing. I think there are recommendations based on people's experience. But I always said, be exploring, you know, be brave to go outside the box of what people tell you, because I don't think I don't follow those actually. I do try something different. I'm from Mexico City, so I like Mexican food, which is very different from what the Mexican food that you find here in the United States. But still, I get like either a red or a white, different varieties, and I try the same dish with different wines, and sometimes I like this one's better than this one. So it's just not a right or wrong answer.
You have a long history of being in the wine industry. So what made you want to go into research?
So I did my master's degree here. Okay, so I started, so let me back up. I did chemical engineering, my background in Mexico City. Then I did my master's degree here. And once I finished my master's degree and I saw how important is research in wine, I always like to be in touch with that. When I went to the industry, because you want to be in the industry to see and to know and to figure out different places. So I was able to be in the Central Coast, in the Central Valley, and the North Coast. So I have a little bit of experience in each side. I kind of know a little bit the vineyards, the grapes, how they are behaving, or what the challenges are in each of those regions.
Real world experience.
Real world experience. And then I see the gap between the industry and research. That's what this attracts me very well when I have this opportunity, because I think if the industry is a little more open to research and working together with the universities or other colleges, I'm not just saying UC Davis, but you're welcome to come here, obviously, but to bring all this knowledge back into the industry to make the wines, they say, control the process in a better way. And we have had some actual solutions for different wineries. Right now in the Napa Valley, a couple of wineries that I know and I've been there, they have the similar sensors that we do have for pressure transducers, so they can monitor the fermentation. They can see it's not going to be a stuck or a sluggish fermentation. So they can anticipate problems before they happen. They can see the redox as well to understand how it's behaving for their own group or their own fruit and the different profiles or styles of wine. So why don't we have more research into this? Like if you see about peanuts, how much research is on peanuts is incredible. A lot of people, potatoes, same thing. But for wine, there's a lot of information, but there's not a lot that has been kind of like going into the industry and applied to the industry.
Why do you think that is?
I think it's because wine industry is very traditional. So you're happy because wine is very easy. Fortunately, we don't have to deal like with the lactic or like a lactose or like a dairy or meat or chicken or poultry, right? We don't have to deal with all the pathogens or all that. We don't have to deal with like saying, okay, potato chips, how long are they going to be, what package, etc., how they taste, etc., right? So we don't need that because the wine itself is delicious and it's easy to make in a sense. However, why don't you express the best out of the fruit, getting a better monitoring, better control to produce what you really want. So I know also other wineries and winemakers decide to go like without inoculation of the yeast. But what do? They have this research approach. They check, okay, what yeasts are we can find in my vineyard? What yeast is taking over fermentation? So they did all the data to be able to control all this fermentation in a very positive way and a positive approach. How much extraction do you want? What your consumer wants, etc. Nowadays, I think we need to also get closer to the newer generations. What do they like? Yeah. Or maybe they just are assuming the same things are already out there. Why don't we give them more options? Why don't we give them more opportunities? Different styles, different varieties, not just the common ones that we know and are more famous, but I would say be a little more adventures to try. So that's what research for me was very important. I was missing that when I was in the industry, and being here is just amazing. Yeah, I always been a part of like ASCV, which is American Society for Enology and Viticulture, which a lot of professors are part of it. And as a student, I started being part of that association, and that will give me back to like knowledge and like, oh yeah, this is the true knowledge, not just oh do this, do that, just this regular processing, but how can we make those processes better?
Yeah. Okay. That's good.
We have webcams to do Zoom, so I do a lot of online classes as well. Catherine Lee, she's, as I mentioned, part of the team, full staff here. So you met Thurman, this is Catherine. She's mainly in the lab, but she also helps in the cellar. We have here, maybe I'm gonna let Catherine to explain to you what equipment we have and what do we do here.
Hi, I'm Catherine. So over here we have our auto titrator. This is used for reading pH, TA, and free and total SO2s. Over here we have our gallery, which is our automatic analyzer. We use it to run enzymatics such as residual sugar, malic acid, acetic acid, things like that. We have quite a lot going on in here today. So over here we have our alkalizer. This just reads alcohol, or you could do potential alcohols, but with that comes with calculations. Yeah, so that's, kind of it. That's the biggest part of this lab.
Okay, in here we have a collection of different wines that are donated or were donated to us, as well as our own label. This is a very beautiful room.
So the wines were donated, and how do you use the donated wine?
It depends. So we have different events, and for those events, depending The nature of the event, we require like a permit for serving alcohol on the winery, and in the campus in general. So we have to have a special permit for that particular, and we have to say what are we
Are these
offering.
fundraising events, or are they just events where people get together and just taste the different wines, just to learn about?
A lot of times it's mainly for learning and demonstrating the different, or people coming for giving a speech about a particular project that they work in, and they're going to work with the winery or the university in a particular project. Then we provide some wines just for as appreciation. So a lot of times we do this for appreciation as well. So we have wines donated from many wineries, and also you can see some of those wines are the ones that are made with our own grapes. So we have our own label. So you see the best Oakville Station. Obviously, this was not produced by us because we cannot sell, but we sell the grapes and we buy the wine. Pretty much, it's just ridiculous. But here is where it says who made it. This is our Albarino, and this was the first year was 2019. We made this with the help of other wineries. So some wineries are very helpful, and then they do collaborate with the university to projects, to research, or to making wine for us as well. Some of them are very special. For example, this is from the T.J. Rodgers Clos de la Tech that you mentioned.
Okay.
The peculiarity, this is T.J. Rodgers' mom, and this is a chip, right? So they have to have their cypress chip for each of those
Really?
bottles,
So can you
right?
check
Mm-hmm.
to validate that it's truly theirs.
Yeah, he did like he will have this personalized for the team that was working in
Okay.
Cyprus. On Cyprus, they will have their own chip in the bottle, and then so here is where they are located and all that. So here we have a lot of. I mean, obviously, some of those have a name of somebody donating it or some type of appreciation. So we have all of those photos. Some others have this is for Ralph Conkey, and so on. So we have from many places. 79, for example, bottle. We have older wines in this one on this side, newer wines on the other side.